Okay, now let's use the decimation for two applications. Number one is the image transmission, and then we have the image blending. Let us consider we are transmitting a small 8 by 8 image from our transmitter to the receiver side. However, due to the channel capacity, we need to reduce its size, and the two resolutions that are available to us are a 4 by 4 and 8 by 4 by 4 and 2 by 2. So during this process, when we are reducing, we are basically using the Gaussian plus decimation, and in fact what we are doing is removing the details from our image. So if we have this 4 by 4 or 8 by 8 image available at our receiver side, so this would be the smooth version of our original image. Let's call this 8 by 8 as the original image. So this is what we would be having. However, we cannot reconstruct the original eye image using these smooth images either using 2 by 2 or 4 by 4 resolution because we are missing the details from there. So what we really want is that we want low resolution to be transmitted, but we also want the details to be transmitted along, and presently we do not have those details available to us. So now let's talk a bit about the numbers here, that what would happen if we send different resolutions. So if we are sending all of these resolutions, so 64 plus 16 plus 4, so we would be sending 80 pixels. So we in fact would be adding an overhead of 0.3%. However, if we send 16 pixels for 64, we would be saving 75% from there. Okay, so we really want these low resolution images plus details to reconstruct our original image. So one more thing, that this thing what I generated here is basically a pyramid, and this specific pyramid is Gaussian pyramid. So we want low resolution image, but we want details to be sent along as well. So generally we achieve both of these stuffs by using, let me show a system there, by system something which is shown in the figure. So look here, this is my original eye, let's call this I, then this is I dash, which has lower resolution in comparison to the first one, then I dash, which is again having low resolution, and finally we have a very small image that we have at this level 3. So we want details and we want low resolution. So look here, when this I or G naught passed through G0, we generated this G1. Similarly G2, similarly G3. So what we can do is, to extract the details, we gonna upsample this G1. So we are passing it through the F0, and once it is upsampled, we would be subtracting it from G0, we would be generating I0. Similarly, we would upsample F1, and then this G1 and whatever is the upsampled version would be giving us the I1. Similarly, this G2 here, this would be minus G3, so this would be I3. So now look here that even if I send this image, then I have details available to me in terms of these various resolutions. And if you look here, these are the high pass variants, and the high pass variant is basically the Laplacian pyramid. So practically what we would be doing is we would be sending G3 plus I0, I1 and I2. Okay, so this would be able to generate the final I dash here, which would have same details as we have the I here. So now let's call it IR. Okay, so what we would be doing is that we would be sending this G3, we would be upsampling it, and then we would be adding I2 to it. So we would generate basically the reconstructed version of our I dash dash. Similarly, this reconstructed version would pass through F1, and then we would be adding I2 to it. So this would be I dash R, and then we would be having the IR version after we would be adding I0. But look here, even if in this representation, if you look, we are actually adding the overhead. Why? Because look here, if let us consider this was 8 by 8, so we are actually sending this 8 by 8, 4 by 4, 2 by 2 along with our let's ideally call this single pixel, although it seems it is of resolution more than that, but ideally let's call this as a single pixel. So we are in fact adding the 16 plus 4 plus 1, that is basically 21 pixel overhead to our original 8 by 8 image. So can we do better than that? The answer is yes. Why? Because if you go through these I0s, you or I1 and I2, you would come to know that the major part of these images is actually composed of zeros or very low values. And you could use different types of the coding techniques to basically make use to save on the memory side. So one such encoding could be, for example, entropy based, and using this entropy we would be actually saving on the on these Laplacians. So this was basically our talk about the Laplacian or the image transmission using the Laplacian and Gaussian pyramid.